All right, let's dive into one of the most talked about, most hyped pieces of technology out there right now, the large language model, or LLM. You've definitely heard of it. It's the powerhouse behind things like ChatGPT and all those creative writing tools. But what is it actually doing? How does it really work under the hood? Well, let's find out.
To start, just try to wrap your head around this idea. Imagine reading every single book, every article, and every website ever put on the internet, and then, somehow, remembering all of it. That, in a nutshell, is what a large language model has done. It's been trained on a data set so ridiculously huge, it's like a digital library of all human knowledge.
And the impact of this has been, well, staggering. To put it into perspective, when ChatGPT first came out, it soared to 100 million users in just 2 months. That's faster growth than Instagram, faster than TikTok. It's pretty clear this tech has captured our imagination. So, what is this thing really?
To get started, let's use a simple analogy that I think really helps. Let's think of an LLM as the ultimate all-knowing librarian.
Now, this isn't just any librarian. This one has read every single book in its spectacular library. So when you ask it a question, it doesn't just point you to a book. No, it synthesizes an answer based on everything it's ever consumed, giving you a response that feels incredibly insightful. And that leads us to the most important question, right? Does this librarian actually understand the information it's giving back to you, or is there something else going on entirely? This is where that friendly librarian analogy starts to fall apart, and honestly, where the reality gets a whole lot more fascinating. So let's pull back the curtain. A much more accurate way to think about an LLM isn't as a librarian at all, but as an incredibly sophisticated, well-read guessing machine.
And this right here is the absolute key difference you need to remember. A search engine like Google finds existing information on the internet and gives you a link to it. An LLM doesn't find anything. It generates a completely new sequence of words from scratch in response to what you asked it.
So how does it generate that answer? Well, it all comes down to probability. At its very core, an LLM is a prediction engine. At every single step, it's making a highly educated guess by asking itself a very, very simple question over and over again. Based on all the text so far, what is the most likely word to come next?
This chart illustrates it perfectly. You give it a phrase like, the cat sat on the, and the model just runs the numbers. It calculates the probability for all the possible words that could follow. Matt might have a 64% chance, Floor might have a 17% chance, and so on. Every single word it writes is the result of a mathematical coin toss.
Okay, so you might be wondering, if it's learned from the entire internet, how on earth can all that information fit on a single computer? This is where a different analogy is super helpful. Think of an LLM as kind of like a lossy JPEG file, but for all of human language instead of an image.
I mean, just look at this number. The GPT-4 model is estimated to be around 570 gigabytes. Now that's huge, for sure, but it's still small enough to fit on a regular desktop computer. The internet it was trained on? That's almost unthinkably vast.
So here's the trick. Just like a JPEG file discards some visual data to make the file smaller, an LLM doesn't memorize the internet word for word. Instead, it compresses it. It learns the statistical patterns, the rules of grammar, the relationships between concepts, and it keeps just enough information to reconstruct language in a way that makes sense.
So, if it's a compressed version of human knowledge, where does all of that knowledge actually live? Well, the answer lies in something called the model's weights. Model weights are the heart and soul of the LLM. They are literally billions of numbers, these tiny parameters inside the neural network that get tweaked and adjusted during training. You can think of them as all the little knobs and dials of the machine. The final values of these weights are what give each model its unique personality, its unique capabilities. This is where the AI's intelligence actually resides.
And getting these weights just right is a two-step process. First, you have pre-training. This is where the model is fed that massive library of internet data to learn grammar, facts, and just general knowledge about the world. Then comes fine-tuning, where it's trained on a much smaller, more specific data set to get really good at particular tasks, like having a conversation or translating languages. And the scale here is just mind-boggling. The GPT-3 model, which is a few years old at this point, has 175 billion of these parameters. The newer models, they have trillions. Each one is a tiny piece of this giant puzzle that allows the model to generate text that feels so human.
Now, when you create a digital brain that's this powerful, it's obviously going to raise some pretty big questions. And that brings us to one of the most heated debates in the entire AI community today.
And that debate is all about whether these model weights, the brain of the AI, should be open or closed. Open weights means the company just releases the model for anyone to download and use. That's great for transparency and innovation. On the other hand, closed weights means the company keeps them private, arguing that it's safer and it protects their commercial investment. Both sides have really good points, and it's a huge tension at the core of AI development.
But here's the thing. Whether they're open or closed, these models have some serious limitations you have to remember. The biggest one is called hallucination, which is just a fancy word for making stuff up. Because they're just predicting the next word, they can generate text that sounds totally plausible, but is factually wrong or just complete nonsense. And on top of that, they can reflect biases from their training data and, of course, pose security risks. They're not perfect oracles.
So what's the big takeaway here? Well, while it can feel like pure magic, an LLM isn't thinking or reasoning the way we do. It's an incredibly powerful pattern-matching machine that is just predicting the next word over and over again. It's not magic. It's just a very, very well-read machine. And now you know how it works.